A lot of times in statistics, you will hear about set theory. Now, I want to discuss what are sets. Now, when we talk about sets, we are talking about a collection of things. Now, just the word set is just a collection of objects, or I can call them entities. Now, by saying collection of objects, now I know I'm talking statistics, but that is actually what it really means. Now, in my hand here, I have a collection of colored pens. Now, because these colored pens are distinguishable and you can see them, you can name them, we can call this a set. Now, in statistics, a set is a collection of things. They must be distinguishable, a collection of distinguishable objects or entities. And for us to say we have a set, let's say set A, in statistical sense, we must be able to, number one, list the objects in the set. So it is not a set if you cannot list the objects or entities that belong to that particular set. Now, as I said with my pen, my set, it consists of different colored pens. I will have orange, green, whatever this is, green, blue. Now, also, for items to belong to a set, or for me to say I have set A, I must also, if I cannot list the object, I must be able to give a rule by which I can decide if a certain object belong to my set. Now, if I say that set A consists of different colored pens, now, does this calculator belong to the set? No, it does not, because according to my rule, it must have a color, it must be a pen, so it must be able to write something down. So even in statistics, when we say a set, you can either list the object that belong to the set, or you must be able to give a rule by which you can decide whether a certain entity belongs to your set. Now, let's write that in mathematical sense. Let's say I have a set A. Now, if I can list the elements that belong to A, let's say we have the letter M, L, M, N, O, P. Now, this is a list of objects that fall into my set A. Now, L belongs to set A, M belongs to set A, N belongs to set A, O and P belong to set A. Here I have provided a list of all the entities that belong to my set A. And there's not this. Now we say they belong to set A. Now if we write this down, we can say M belongs to set A. And here I have my list of entities. Now, if I cannot list all my entities that belong to a particular set, I can also provide a rule, right? We said you must give a rule to decide whether an entity belongs to a particular set. Let's say in this instance, my rule says for set B consists of odd numbers between 1 and 10 inclusive. Now, this is my rule. It says that set B consists of odd numbers between 1 and 10. Now, on this planet, there's an infinite number of numbers. I can count from 1, and you can never reach the end of numbers. You'll keep going high and high. So here, though, all those infinite numbers do not fall in my set B, because my set has a rule as to which numbers can fall into it. And that rule is that these numbers must be odd, and they must be between 1 and 10 inclusive. Now, when we say inclusive, we mean 1 and 10 are part of my consideration. Now, between 1 and 10, what are the odd numbers? I will have 1, 3, 5, 7, and 9. 10 is an even number, so it does not belong to my set B. So out of all the numbers between 1 and 10, my rule can decide which ones belong to my set. And if maybe I got 7 as my result of maybe an experiment, then I can say yes, 7 belongs to set B. Why? Because 7 is an odd number and it is between 1 and 10. Now, let's try another rule. Let's say my rule determines that for a set C consists of real numbers between 1 and 10 inclusive. Now, for a set C, there's a rule that said numbers that belong to my set C are real numbers between 1 and 10. Now, inclusive, including 1 and 10. Remember that every number between that range is a real number. 1 is a real number, 2 is a real number, 3, and they are between 1 and 10. 1.532168810 is between 1 and 10 and is a real number. So it will fall between 1 and 10. So it is sort of a range now. Here I gave you a list exactly. Now I provide you with a range for my set. Now I will say set consists of real numbers such that x is greater, since it's inclusive, it is greater or equal to 1 or less than or equal to 10. Now, you must have noticed that by now, for each value, when you list the entities that fall into a set, you will use this nice brackets that I keep making. Mine seems to be the ugliest. I don't know why. Now, let's check. Does the entity say you obtained 8? Does it fall to set C? No. Yes. Yes, it does, because 8 is a real number and is between 1 and 10. So 8 does belong to set C. Now, these entities that are here, mathematically, how do we represent them and say they belong to a particular set? The way that we are going to write this down is by saying, take these for example. Now, L, since L belongs to set A, we are going to write a nice E here and write A. Now, this notation says it's for element of. That's how we write it. So since L belongs to set A, in this notation it represents that L is an element of set A. Now, another element of set A is P. We can denote it in this way and say P is an element of A. Now, let's take 3. Is 3 an element of A? No, it is not. It is an element of B. Now, in A, I only have L, M, N, O, P. 3 is not part of those. So we say 3 is not an element of A. Now to say that it is not an element, we will write down this diagonal line to say not an element of. Now, is M an element of C? No. In my set C, I have real numbers between 1 and 10. So M is not a number between 1 and 10. So M is not an element of C. Now, let's suppose that I have a new set, and my set is called set C. And in set C, I have the numbers 2, 4, 6, 8, and I have the letter Q, X, W. And all of these entities belong to set C. So 2 is an element of C, Q is an element of C. And now I introduce a new set, and that set is called set D. Now, set D has Q, W, 4, 8, X, 2, 6. Now, what you may notice is that all the elements of C are the same elements in D, but they are not arranged the same. So the rearrangement of your entities as you list them down, it is not relevant. Set C, it is said to be equal to set D, even if the elements inside your set are not arranged in the same way. As long as they exist in both sets, then set C is equal to set D. Now, taking in consideration that set C of mine, let's say I have a new set, and my new set is provided by set F. And that set F consists of 2, 4, 6. And that's it. It only has 3 elements, 2, 4, 6. Now, is set F equal to set C? No, it is not, because set F only has 3 elements that are in set C and does not have the rest of the 4 elements. But what we want to take notice here is that every element of F belongs to C. So all of the elements in F 2, 4, 6 are in set C. We have 2, 4, 6 in C. We just have more elements that are in that set. Now, if there's a set that exists and every element of it belongs to another set, we call this set a subset. Now, a subset is when every element in one set belongs to another set. Now, D here and C, we said they are equal. So we can also say they are subset of each other because every element in D exists in C. But this one, whereby they are not equal, but one set has elements, all of its elements belong to another set. We call that a subset. Now, the way that we are going to represent this in mathematical terms is to say F is a subset of C. Also, you may notice that all the elements in F exist in D because there is 2, 4, and 6 in D. So F is a subset of D. And that's how we represent it in mathematical terms. Now, let's look at set A. Set A has L, M, N, O, P, while set D has Q, W, 4, 8, X, 2, 6. Now, is A a subset of D? No, it is not, because no element in A, every element in set A do not belong to set D. So A, it is not an element of D. Now let's look at B and C. Now in B you have 1, 3, 5, 7, 9, and C has all numbers between 1 and 10. Now is B an element of C? Yes, it is, because every element in B belongs to set A, and that's how you represent it in mathematical terms. You can always twist it around and say D contains F. Different notation, but they mean the same thing. F is a subset of D, and D contains F, and that's what sets and subsets are. In the following videos, we'll talk about their operations when we talk about unions, intersections, empty sets, and mutually exclusive sets.